All right, well, welcome to the 2025 technical meeting. I'm the first presenter, so I'm going to warm up the audience for the subsequent presentations. So I'm going to talk about two bat species that are sort of time sharing a cave on Fort Huachuca in southern Arizona. My co-author is Debbie Brewer, which is always confusing because we talk Debbie. No, you mean the other Debbie. She's a wildlife biologist with the Environmental and Natural Resources Division on Fort Huachuca. So if you don't know where the Huachuca Mountains are, here we are. Here's Tucson, and the Huachucas are sitting right on the border with Mexico. So when we look at the Huachuca Mountains, I'm not sure if some of you are aware, but they actually are in the Madrean Sky Island archipelago. So all of these are mountain ranges, and they're sitting surrounded by either desert scrub or semi-desert grassland. So they're stacked biotic communities with varying temperatures and humidities. And so there's a lot of diversity on these sky islands. There are about 27 sky islands in Arizona and about 15 in northern Mexico. And the importance of this is it allows gene flow from the Sierra Madre Occidental across all of these sort of interconnected. I mean, it's biogeography, but there can be dispersal, and it's gene flow all the way up to the White Mountains and the Mogollon Mountains. So because it's proximity to the tropics, it contributes to tremendous biodiversity across the region because these are, the arid base, but then there are all these biogeographic components. So the Huachuca Mountains take up about 755 square miles. They're right on the border with Mexico. The elevation ranges are from about 3,900 feet up to Miller Peak at almost 9,500 feet. Fort Huachuca is right on the northern end of the Huachuca Mountains, and it was established as a cavalry fort in 1877. There was cattle rustling, horse thieving. The OK Corral was just a little bit before here. There were still skirmishes with the Apaches. So it really sort of became a law enforcement cavalry fort, as many of the Western cavalry forts were. The area is about 73,000 acres. It varies from about 3,900 feet to 8,600 feet, and it goes from that grassland surrounding that island up to mixed conifer and up rugged canyons. So it really speaks to this diversity, again, for wildlife. So it offers a lot of bat resources. We have documented 17 different bat species across 3 different families. And these are just some 8 of the faces of the bats that we have captured. We have documented 2 additional bat species from acoustics, but they're bigger bats and they don't come into those smaller pools in the canyon, so we haven't captured them physically. So the Fort Huachuca Mountains it used to be permanent water in the canyons, but we're in this tremendous drought, and a lot of it now is ephemeral water. But last winter we didn't have any rain, and so it was really hard for bats to find water across the fort. But besides water and then insects, because of the deciduous vegetation, there are a lot of roosting opportunities with the cliffs, the trees. It's sort of bat heaven. It offers everything that bats need. So I'm actually speaking about a project that was started in 1989. And the main focus of this was to monitor sensitive bat species. The lesser long-nosed bat was endangered then. So that really was the focal species. It was delisted in 2018, but Department of Defense is still tasked with protecting the sensitive species on the fort. It's a DOD. So it's really sort of incorporated 35 years, and we really focus on low disturbance monitoring techniques. So we're tasked with monitoring bats at 9 different known bat sites, and if a new site were to be discovered, we would incorporate that in. We maintain infrared bat counters at 3 roosts, and I'm going to talk extensively about these infrared bat counters. And we conduct emergence counts and video documentation at about 6 roosts. And we have microclimate loggers in the 6 of the bat caves. And we only go in the winter when the bats are gone to trade those out. But we are keeping track of the microclimate where the bats are roosting. We maintain a pit tag reader at the cave that I'm going to be talking to you about, and that would be a whole different talk, because we're documenting bats coming up from Mexico that have been pit tagged. And now, of course, recently we are misnetting in the spring and swabbing bats across those 17 species for presence of the fungus that causes white nose, and then we also look at the membranes for damage. So the first of the 2 bat species that I'm talking about is the cave Myotis, Myotis velifer. The cave is a summer maternity colony, and they're insectivorous bats. They come out of hibernation sort of in April and start moving into the roost in May. They give birth in late June and early July. And so you can see, you can do exit counts of adult females. The young can usually fly by early August, so you see a pulse in that population. What's interesting is it is a maternity colony, so almost immediately after the young can fly, the population of the cave Myotis starts going down. They're moving to swarming or mating sites where the males come in, so they're using August, September, and October in other areas where they're mating. The other bat species that I'm talking about is the Leptonycterisyerbabuenae. It's the lesser long-nosed bat. It's the cave that I'm talking about is a post-maternity site. So it's after the young can fly. This bat species overwinters in central Mexico. And as the cacti, columnar cacti, start flowering along the west side of Mexico, these bats are following and feeding on the nectar and the pollen and pollinating these plants. They're pregnant and they get up to northern Sonora, southwestern Arizona, and they give birth to 1 pup. So now they're kind of stuck in that area until the young can fly, but they're feeding on the columnar cacti, nectar and pollen. And then once the fruits form, they come up and get a big gulp of that pulp and ingest the seeds. And the seeds go through the digestive tract and are left as guano splats away from the parent plants. And so they're really critical for cross-pollination, because these animals can fly 30 miles one way. And so they're really cross-pollinating all the columnar cacti, and then they're dispersing seeds. So once the young can fly, these animals migrate across to southeastern Arizona and southwestern New Mexico in the boot heel and start feeding on the flower, nectar, and pollen of the century plants, the big paniculate agaves. And the young have to put on fat reserves, and the females have been nursing, so they have to get their fat up, because then they're going to migrate back into Mexico to overwinter. So for a short period of time, these 2 species are occupying the same cave, time sharing. So for the insectivorous bats, they can feed on the grassland, they can go up into the canyons, they can go up in elevation to find insects. But for the nectar bats, this is their search image. These are the century plants that you see coming out of the grasslands surrounding the Huachuca Mountains and a lot of the other sky islands that are in southern Arizona, which is important for these bats. So this is what these rosettes, these plants, grow for about 25 years. And then they put all of their energy into this huge stalk, and it doesn't take the stalk much more than about a month to really emerge. And they flower from the base up to the top. And the fact that they're a paniculate and these flower stalks are out away from the plant allow the bat to come in. They get a drink of nectar, they get pollen all over their face, and then from plant to plant, they're cross-pollinating these agaves. So I'm going to talk about the ways we study these bats. So one of the main ways is an infrared bat counter in the cave that we're talking about. It was designed and built by my late husband, Bob Buecher. It uses Arduino technology. And when a bat breaks the beam, there's an element down here on the floor, an element on the ceiling with an infrared beam. And when the bat breaks that beam, it assigns a date and time stamp to that event, and then produces a 1 minute total. So what this looks like is date, time stamp, and 225 times at 8:10, the beam was broken. And so you can start, relating how many bats are coming out of the cave. So the first slide showed the entrance. I'm standing in an entrance room, but this is the small entrance that the bats have to come out to get in the entrance room. And there's staging issues when they're really coming out in large numbers. Well, all of this technology was in Bob's brain. So when he passed away, the first couple of years, I could maintain the counters, but then electronics got old and started to fail. And so John McLean, who understood Arduino technology, stepped up, and he took Bob's counters and reverse engineered them. It built me some additional units and did documentation, which Bob should have done, with a user manual, how to build them, how to program them. And so we're in really good shape now to continue this data set, which is like 35 years. So let's look at an example plot of the entire night coming out of this bat counter this is the pulse of the cave Myotis coming out. This is the pulse of the leptos, the nectar bats coming out. And then this is the activity through the night, and then they come back right about dawn. The second method that I use is infrared cameras and infrared lights. I specifically put it out from the bat's flight path. I don't want them coming at me and getting totally free. So I'm looking at the cave edge on, and the bats are flying out this way. These are infrared lights, the infrared camera, and I videotape until the flight is essentially over. And that can take 1 to 2 hours. So here's an example of what I get when the cave Myotis are leaving. This is not speeded up. This is as fast as they're coming out. And I have an inventory counter, and I'm going 10, 10, 10, 10, 10, 10. But when I get home, I can slow the video down into really, really slow. And then I can get a much better sense of how many bats came out. So then I can actually go and every minute tally what I've got, and you can look at the emergence. Usually it's a bell curve. They sort of this night decided, whoop, we're leaving. And so it's a little steeper. But this night, 5,800 cave Myotis came out. This is when both species are present on the landscape. So this is the cave Myotis. They always come out first. They come out about 20 minutes after sunset. And then fortunately, there's a little bit of a lull, a couple minutes, and then the leptos come out. So now we can look at that night-long behavior from the infrared bat counters. So if you look at June 15th and 16th, this is when the females are pregnant. They leave the cave. This peaked at like over 200 a minute, and it only took them half an hour. Now they can go some distance to forage. They don't have to come back to the cave for any particular reason through the night. So they go off, they can night roost, they can go on 1 or 2 more foraging bouts. And so they're essentially dribbling in all night. But when you look at when they're nursing, they've given birth and they're nursing, you can see that the behavior has changed. It went from 200, now it's taking 2 hours to come out. They're nursing, they're grooming the pup, and the pup can't go the entire night without being fed. So about every 4 hours, the females are coming in and out and nursing, and then maybe going for a second foraging bout, and then coming back in. And if you lay those on top of each other, you can start looking at behaviors of when they were pregnant, when they were the week they were giving birth, when they're lactating. So you can start looking at behaviors that are really useful. So when we look at August 9th, when both species are on the landscape and they're using the cave, this is the cave Myotis pulse, little lull, the leptos, and then all of this activity. Now, there are a lot of flowering agaves at the beginning of August. And so they don't have to go distance to forage. They go out, they go around the hill, they get a drink, they come back. And this is essentially sugar water. It's like giving a 2-year-old a Snickers bar. They are wired. And when I'm counting, right after the leptos come out, I can look up and there'll be 20 or 30 bats above my head chasing. The young have just sort of figured out, they have learner's permits. They've come from the maternity sites in Sonora, and they're wired. They're in and out and in and out. So it's a pretty crazy time. But once later in the season, the agaves have finished flowering on the fort, you can see that they leave and they can't afford to just fart around. They may have to go to an adjacent sky island 30 miles away to feed. And so you start seeing this really different behavior by the colony. So this sort of allows us to look at summer-long behaviors, individual behaviors. And when I come down and I do those manual counts periodically, and when I count how many bats and I put it on the x-axis and what the bat counter does on the y-axis, I can develop a regression line. So here is my actual visual counts, the infrared bat counts. This isn't really a great regression, but the reason is this puppy. This is when the leptos have peaked and they've totally overwhelmed the bat counter. The counter just can't keep up. It can't reset in time. So an example of that when the leptos are coming out is this. And this has probably ended up being 12,000 bats over the time that they came out. And the poor counter just can't deal with that. So if I take off that outlier, which is really only about a week or two, I take that out, the regression gets much better. So most of the summer, I can look at the infrared bat counter and I can say, I wasn't there that night, but this is probably how many bats came out. So by combining the infrared bat counter and my manual bat counts, I can look at behaviors both within and between the species and look at that, how they're time sharing the cave. Acknowledgements, the fort has been tremendously supportive. Some of it's because they have to be with DOD. Dr. Ronnie Seidner and I started this. She was the initial PI in 1989, and she was the PI and I was the technical support safety officer because she'd never been in caves, and so I was keeping her safe. The environmental and natural resource biologists that were really significant were Sheridan Stone and now Debbie Brewer. And my field technicians were Bob Buecher and Scott Clemens, who both passed away. Mike Doe is important. My new technician is George Simons, and John McLean has allowed this study to continue at its importance. Here we're misnetting under a bridge. It's a night roost. This is Debbie Brewer, Bob Buecher, and Betty Phillips, who is another ENRD biologist. Questions? Yeah.
One singular, like one singular, or
yeah.
Sort of multiple?
What Bob tried to do so that he had a beam and a beam so he could tell if they were leaving or coming in, but they're so fast and you couldn't just really get And so he tried it, and it just wasn't giving. So it is a single beam. Now they can go in and out. It's just breaking the beam.
Okay, so it counts both in and out, so you're dividing in half.
What I do is when I get the total number at dawn, I generally cut it in half. Now, if there's a storm outside, you'll see I'll plot it and there'll be this big peak at sunset, but it's because they're circling and there's lightning and there's rain, and I have a nearby weather station and I can see the conditions. You know, suddenly the population goes up. I know it did. So
Pathway itself is very small.
it's this and that entrance. Yeah, if you put it anywhere in a little further inside or in the entrance room, you could avoid so many animals that this really sort of speaks to the best place to put it. Yeah. Yeah.
Changing patterns having bearing on mom timing their babies again and come back and because it seems, you know, it's a
Thousands.
task, you know.
Yeah. So this was actually until the 60s, bat biologists said, well, you know, say in Bracken Bat Cave, millions of bats. How does, you know, mom can't find her pup, so she must nurse the first pup that comes to her. Genetics, no, you don't invest in that. And so Gary McCracken, who is a bat biologist, really important bat biologist, his doctorate was to mark pups and young. And if this were the cave room, mom leaves her pup here. She doesn't start looking for her pup anywhere else. She goes back, she's nuzzling pups, rejecting them, nuzzling, and the pups are climbing around and peeping, and mom's calling and calling, and he could document that they come together. So that was finally documented in the 60s. Yeah.
David, I really appreciate you giving us the history of this whole project and all the people involved in the project.
Yep.
Listing Sheridan Stone and all of that. Thanks for.
Yeah, Sheridan Stone,
honoring all of
I mean, the cave had an incredibly bat unfriendly gate. And the service people went in spelunking every weekend. There were no bats in the cave in essentially 1989. And I could have shown a plot where the cave Myotis discovered them and the cave Myotis population increased through time. Took a little bit longer for the leptos to find it. It's a fabulous microclimate. It allows the bats to roost in sort of a neutral, thermal neutral, so they don't have to expend a lot of energy. It's really humid. It's an critically important roost.
And did you know that historically from back state?
Bat bones and Hofmeister had done, early people had done work and talked about bats, but then the spelunking just chased them away. So there's a perimeter fence, locked perimeter fence now. There's no constriction except natural cave passage, and they've totally stopped spelunking in the cave.
Roost together?
They don't intermingle. If you go in, you see guano piles in certain spots where the cave Myotis are roosting and having their young. So there's a nice guano pile. You go in and there's lepto shit everywhere. I think they're just flying around. I know they do roost in certain areas, but I can go to the back of the cave. It's lepto shit. It looks like someone took a paintbrush with yellow paint. See, they're drinking nectar, and it looks like yellow because it's full of pollen. So it looks like someone went like this with yellow paint.
Early.
Yep.
So do they have different targets for food?
Yeah, one is insectivorous.
But they don't seem to compete.
No, the insectivorous bats leave, and that's sort of, even at Karchner Caverns where we have cave Myotis, they leave within about 20 minutes after sunset. It's just that I think the staging with that little entrance, the leptos have to kind of delay their emergence at this site.
Have you plotted the annual rainfall against the blossoming of the
Great question.
plant?
It's a great question, John, because of this year. He asked about plotting rainfall and the blossoming of the century plants. Well, these plants grow for 25 years. It's not like they immediately can respond. So we had almost no flowering agaves on the fort this year, almost none. A hill that I counted 30 flowering agaves last year had 5 this year. And so the behaviors that I plot are different. They're having to go further. I don't get that really busy activity because there were so many agaves. They've had to go look. And I tried different sky islands. It was sort of a failure of agaves this year. Now, if they've grown for 25 years, it could have been 25 years ago something happened. So there weren't a lot of pups that came out. And it's hard to tell if it was our winter rains were non-existent or if it's the bigger picture because these plants are programmed at such a broader scale. But I finally found a canyon that had a lot of agaves, but where I typically went and you could see all the grassland and all these century plants, nothing. So we're hoping this is an anomaly, not something that's now going, because it'll affect these bats. They have to put on fat reserves to migrate back to Mexico.
Have those flowering agaves that's way down, overgrown in Mexico, southwest Mexico, but do we have those nectar bats?
Yes. The Animas Mountains, the big hatchets, there's a lepto roost in that area. And we've discovered a lepto roost in the big burrows. Because the big burrows have agaves and the grasslands down in the Buecher have agaves. So the range is kind of southeastern Arizona and southwestern, the Buecher of New Mexico. So yes, you have leptos in New Mexico. Yeah.
I'm gonna go online where somebody said maybe you could use AI to improve your compost.
Yeah.
So I'm just passing the comment.
Yeah.
Online person.
Yeah, I'm this computer person. I'm gonna look into AI. I can do an inventory counter at 1/3 the speed. Thank you very much. Do you want to put up the next?
Thank you.
Thank you.